So you're basically always going to use the KSP equals the two different things. You base it off of like that formula, and you're just going to solve it, correct?
Yeah.
I like it though. So if I get a 2x squared plus a 1.5. Any fun plans for the weekend?
If it works out, hopefully we're gonna go climb some mountains.
Where at?
Lost River Range.
Wait a sec. So if I'm just gonna set this up, when I subtract 1.5 over to there, okay.
Yeah, and then this is always something I did wrong, that becomes 4x squared.
Oh, okay, I'm
It's
glad you
just
said that.
Squared. And so...
Can you take a square root of a negative number? I can't remember. So try it.
Oh, no. Sorry, that's not a plus, that's our problem. Because it's times.
Okay, okay. I was like, these seem a little bit different,
Yeah.
but I'm just gonna follow. I'll just blindly go.
Sorry.
Okay. Okay, that should change it up. It's a really small number. Okay. Gives me a pretty small number though. 1, 2, 3, 6, 7, 4.32 times 10 to the negative 7th.
Sounds about right.
That's my molarity?
Yeah.
It's a really small amount. It seems so weird that you'd even work with that little stuff.
Yeah.
So then we have the silver. Oh, we were doing these problems yesterday. Okay. Now I gotta figure out the silver nitrate in the aqueous solution.
Yeah, so same thing except for I'm gonna erase this so we have more room here.
Okay.
And this changes to, so what's our molarity of silver or whatever?
1.5 moles.
Okay. So that breaks apart into silver. Well, what is it?
Oh, silver nitrate.
Nitrate.
Is that NO3?
Yeah. So then you have 1.5 here that you start with, 0 and some, and minus x, plus x, plus x, or plus 2x.
So then you got, okay.
And so then your KSP equals
1.12 times 10 to the negative 12, which is equal to 2x squared.
plus 2x squared times x.
Oh, it's still separate, okay.
And your KSP stays the same. 1, 2. And you could ignore x again, this 1.5 squared times x.
Oh, you can totally just get rid of that. Really?
Yeah, because it's going to be such a small number that when you add it to 1.5, it's going to be like 1.500003 or something. anytime you're adding an x, you can, but when you multiply by an x, you can't.
Okay. Even with it being a 2x, it's still good. Okay.
It's still small enough, you can get rid of it.
It's a small number again.
That just tells you that, and I think Ag2CO4, that's just not very soluble in water.
Oh, it makes sense. So there's even less silver being dissolved, huh?
Yeah.
Okay, that makes sense. Yeah, because if I dropped a piece of silver in the water, I don't really think I'd have a whole lot. Now in pure water, not, okay. So this is still based off of the silver chromate, right?
Well, now if you're in pure water, your initial concentrations are both going to be 0. So you have some 0, 0 plus 2x plus x.
Oh, okay, so that kind of leaves you with like... So that's pretty much just going to leave you with 2x times x. So you just solve for 2x squared, right?
Yep.
So you solve for 4x squared is equal to your KSP, correct?
Well, it'll be 4x squared times x.
Oh, this goes cubic, that's right. Okay.
So now you got 4x squared times x, which will give you 4x cubed. Yeah.
Okay.
Yeah, so I just looked it up. Silver chromate is insoluble. So that means these numbers should be very small because not very much is going to be able to break apart into ions.
But it's still soluble though.
Yeah, most of these are soluble to a teeny tiny degree, but there's just a cutoff point where they say that's so small that it's basically insoluble.
Okay. Fine. So what are we saying? So silver chromate, when it's put into a pure solution of water, is more soluble than when it's put into this aqueous solution of... Is an aqueous solution? What's the aqueous solution?
So
So we put it into potassium chromate, wasn't that soluble? We put it into silver nitrate and it was even less soluble, and then we put it into water and it was a lot more soluble.
yeah, and that's going along with that whoever guy that made those rules about equilibrium. If you have more of those, more product in solution, then the equilibrium will favor reactants. And so in pure water you have neither of the reactants already, so more will be able to form.
Okay.